Hello and welcome to Walking Talking Mocks with Budehaven Science. We're going to focus on how to calculate masses of reactants and products. We will look at the subject knowledge you need for this question. You will then be given time to answer a 5-mark question before looking at an example answer provided by me. To answer this question, all you need is paper, pen, a calculator and something to time yourself with. This is higher tier material, so if you're sitting the foundation paper, you do not need this for your revision. Higher tier, you should be able to use moles to work out a balanced equation, calculate masses of reactants or products, and calculate concentrations. You do not need to calculate concentrations or volumes in titrations. If you're a triple science student, I'll be doing a separate video for this. I'm going to use this as an example question to help run through the best way to answer one of these quantitative chemistry questions. So let's review what you should know to answer this question. We're going to use moles to compare the masses of reactants and products. A mole refers to a specific number of atoms. It's similar to using miles when talking about distance. Rather than saying I ran 6,400 metres, I would say I ran 4 miles. The same principle is used here. 1 mole is equal to 6.02 times 10 to the 23 atoms. So 1 mole of any element or compound contains 6.02 times 10 to the 23 atoms. The number is often called Avogadro's constant, after the researcher who discovered this idea. We also know that when we have 1 mole of an element or compound, the weight of that element in grams is equal to the molecular mass of the element. Here are some examples to clarify that idea. If you used your periodic table, you could see that carbon has an atomic number of 6, meaning it has 6 protons. It also has an atomic mass of 12, meaning it has 6 protons and 6 neutrons. Now looking at the diagram, we can see that 1 mole is equal to 12 grams. This is equal to its atomic mass in grams. The same is true of all the elements. Because we understand this link between moles, molecular masses and weights, we can use the equation moles are equal to mass over Mr. Mr is an abbreviation used for a molecular mass. So using one of our examples, we can see how this works. 63.5 grams of copper divided by 63.5 as its molecular mass is equal to 1 mole. So if we take this back to the example question, there are a few things we can do before any real calculations take place. Although it may feel time-consuming using this grid, the method is straightforward and more likely to result in the correct answer. It also clearly states your calculations. So mass, this can be taken from the question. The Mr can be calculated from the periodic table. The moles can be calculated using the mass divided by the Mr. The ratio is something you may not have come across. This can be determined by the balanced equation. It's looking at comparing moles of each compound. So with this, if a full mole had reacted, it would be easy to work out the mass. However, it's highly unlikely that you'll be given a question where a whole number is used. This means you can use the principle of the ratio to work out the moles of each compound from just one of the substances. So in this case, there are no large numbers in front of any of the formula. This means that the ratio is 1:1 for all of the compounds. However, as the main mass is larger than the molecular mass, I already know that the number of moles for each is larger than 1, but not a whole number. We only need to look at copper oxide and copper sulfate because the mass of the reactants is equal to the mass of the products, and you cannot lose or gain copper. We can compare these directly. The next thing you can add in is the MR, or the molecular mass. If you do not understand how I've calculated these, see the video linked to calculating formula mass. The only other thing you can add at this stage is the mass you've been given in the question. From now on, it's a case of what can I work out rather than what should I work out. You can do this by looking at the blanks in the grid. At this point, you can only calculate the moles of the copper oxide. So use the mass divided by the Mr to give you the moles. Here, that is 87.1 divided by 79.5, which gives you a rather long answer. You should not round this at this point, as you can produce errors in your final answer. Because of the 1:1 ratio, we know that there are the same number of moles for each of the compounds, so we can add this in now. With this new information, you can calculate the mass of the copper sulfate crystals formed by using moles times Mr to give you the mass. Over to you. Here is an example question for you to try. In a moment, pause the video for 5 minutes and attempt this question. I will follow with the answer. Magnesium reacts with iron chloride solution. See the formula below. 0.12 grams of magnesium reacts with an excess of iron chloride solution. It gives you the relative atomic masses. Now, calculate the mass of iron produced in milligrams. Pause the video now. And here's my answer. I've tried to use a colour scheme to show you the flow of the question. Firstly, fill in the information available, so the mister, the ratio, and the mass of magnesium. Next is to calculate the moles of magnesium using mass over mister. Then using the ratio to calculate moles of iron, it's very basic. Divide the 0.005 by 3 to tell me what the ratio for 1 would be, and then times it by 2. All that then remains is to multiply the moles and the mister to give the mass. But in this question they want it in milligrams, so you need to times it by 1,000 at the end, and it's 1,680 milligrams of iron. If you're still struggling with this, please see one of your teachers or come to our Wednesday revision sessions.